Hello, welcome to the next session. In this session, we'll solve GATE 2011 Production and Industrial Engineering paper. Okay, starting from question one. The question one is if matrix A is equal to 2143 and matrix B is equal to 4569. Okay, then the transpose of product of these two matrices, that is AB transpose, is equal to option A. ABCD are given. Okay, we'll check the answer after finding out the. Okay, so here A is your, this is your A, this is your B. Okay, so first of all finding out their product. Okay, A into B. So the product is two. The first element is 2 into 4 and here 4 into 5, like this. 2 into 4 and 4 into 5. And second element is uh, this element. Okay, this element 2 into 6 and 9 into 4. Okay, and similarly third element, this element 1 into 4, 3 into 5. Okay, similarly last element 1 into 6 and 3 into 9. Okay, so product comes out as this. Okay, and transpose of this product is here, 19 come here and 48 come here. Okay, so answer is your B. Okay, next, if A 043, the coordinate of A, B 000 and C 304 are 3 points defined in X, Y, Z coordinate system, then which one of the following vectors is perpendicular to both the lines vector BA and BC? So this is your point B. Okay, and the BA point is your nothing but BA is your uh, final coordinate. Final. Sorry, subtract this from this. Okay, so it will be 0 minus 0. This will be 4 minus 0, and this will be 3 minus 0. Okay, so the BA vector will be 4J. Okay, so okay. And similarly, CA vector is your BC vector is your subtract this from this 3 minus 0, 0 minus 0 and 4 minus 0. So BC vector is this. Okay. Now let x, I, y, j and z k be the vector perpendicular to both. Okay. For the perpendicular vector, for this vector to be perpendicular on BA, its dot product should be 0. As a dot product is your putting the value of BA. Okay, and this is your uh, required vector. Okay, so this will be your 4y and plus 3z. Okay, equal to 0. And similarly, uh, this is also perpendicular to BC. Okay, so dot product will also be 0. Okay, so this will be 3x. Okay, and this will be 4y. Sorry, 4k. Here is k. So it is 4z and y j. There is no j coordinate. Okay, or no y coordinate. So it will be 0. So 3x plus 4z. So we have four equations. We have two equations. First equation is 4y plus 3z, and second equation is 3x plus 4z. Okay. Now check option by option. So first option is your 16i plus 9j minus 12k. Okay. Here the value of x is your 16, y is your 9, and z is your minus 9. Okay. So this option satisfies. If we put to y is equal to 9, okay, and z is equal to minus 12, then it is 0. Okay, and if we put x is equal to 16 and z is equal to minus 12, then it also satisfies the second equation. So answer is your answer is A. Next, the solution of the differential equation d square y by dx square plus 6 dy by dx plus 9y is equal to 9x plus 6 with c1 and c2 as constant is y is equal to c1x plus c2 e minus 3x b y is equal to c1 ex e3x plus c2 e minus 3x plus x. Okay, and c y is equal to c1x plus c2 e minus 3x plus x, and d y is equal to c1x plus c2 e 3x plus x. Okay, so the differential equation is this. Okay, so this and we'll find out as this is and here it is not zero, so we will be having complementary function as well as uh, particular integral. Okay. So the finding out complementary function, put d square y by dx square d square and dy by dx is equal to d. Okay, so it will be d square plus 6d plus 9 into y. Okay, or d is replaced by m. So this is m is your minus 3 and minus 3. Okay, so the complementary function is your y c is equal to c1x plus c2 e minus 3x. Okay, okay, so complementary because roots are equal. Okay, m are m is minus 3 and minus 3, so the complementary function is your this. Okay, now finding the particular integral. Okay, now on the right side the value is 9x plus 6. Okay, on the right side, and your roots are minus 3. Okay, or or this equation is your d plus 3 square. Okay, so writing out this as d plus 3 square. Okay, now taking 9 as common here, so here it will be 1 plus d by 3 square. Okay, or it can be written as 1 plus d by 3 raised to minus 2. Solving this, okay, so it will be 1 minus 2 by 3d. Okay, neglecting higher order term. Okay, now uh, carrying out and now again solving it. Okay, solving it further. Okay, 9x plus 6 by 9 will mean with multiplied by 1, and the differentiation of this. Okay, differentiation of this is your 9. Okay, 9 by differentiation of this is 9 and multiplied by 2 by 3. Okay, so 9 into 2 by 3. Okay, it will be here 6. So answer is so the by solving is we get 9x by 9. So answer is the x. So total solution is complementary function plus particular integral. So answer is option C. Okay, next the line integral p2 to p1 y dx x dy from p1 bracket x1 y1 to p2 x2 y2 along the semicircle p1 p2 shown in the figure. So this is your p1 and this is your p2. Okay, so this is your these are the mm, uh, coordinate of the point p1 and p2. Okay, and the equation of the line integral is this. Okay, so now y dx plus x dy can be written as dxy. Okay, and the limits are p2 and p1. So its integration is xy, and limits are your x2 y2. P2 is your x2 y2, and p1 is your x1 y1. So putting the value x2 y2 minus x1 y1. So option A is the okay. This is x2 y2 minus x1 y1. Answer is A. Okay, next. It is estimated that the average number of events during a year is 3. What is the probability of occurrence of not more than 2 events over a 2-year duration? Assume that the number of events follows the Poisson's distribution. Option A 0.052, option B 0.062, option C 0.072, option D 0.082. Okay. So we know that in Poisson's distribution, the probability is given by this. Lambda is for x, e minus lambda x factorial. And lambda is your mean. Okay. And mean is lambda is your mean. And mean for 1 year is 3. And as we have to find out the number of the probability of the event of for 2 years. So mean for 2 years is your 6. Okay. As it is given that the average number of events during a year is 3 events. Okay. and we have to find out the probability of occurrence of two events over a 2 year duration. So for 1 year duration, the average number is 3, and for 2 year duration, the average number is just 6. Okay. Now we have to find out the probability for not more than 2 in 2 years. Okay. So which is the summation of probability of occurring 0 event, probability of occurring 1 event, and probability of occurring 2 event. Okay. So now if we put here x is equal to 0, then we get this. If we put x is equal to 1, we get this. And we put x is equal to 2, we get this. Okay. So this is your 0 factorial, 1 factorial, 2 factorial. Okay. So probability is your putting a value e minus 6, taking it common, 1 plus 16 plus, yeah, here it will be 6 raised to 36 by 2, okay, 18. So answer is 0.062. Answer is your option B. Okay. Next, a circular steel shaft is under elastic deformation due to torsion. The relationship between modulus of elasticity E and shear modulus of elasticity G, taking mu as Poisson's ratio, is option A G is equal to 2E 1 plus mu, B E is equal to 2G 1 plus mu, C G is equal to 2E divided by 1 plus mu, and D E is equal to G divided by 1 plus mu. So answer is B. You have to remember the formula. There is nothing to explain about it. Okay. So answer is B. Next, two circular steel bars having same length L are subjected to equal load P. The first bar has diameter D over its entire length, while the second bar has diameter 2D over two-thirds of its length, as shown in the figure. Assuming linear elastic behavior, the ratio of strain energy to first bar to that of second bar is, so this is your first bar and the second bar. Okay. The strain energy of the first bar is, strain energy of any bar is load into elongation by 2. And so for the first bar, the elongation is, uh, this is just, sorry, PL by pi by 4 d stress by E into L. Okay. So, and the strain energy is your P into del L by 2. Okay. So this is your del L and P. Okay. So it will come out as 4 2 P square L by pi d square E. Okay. For the second bar, the load is same for both portions. Okay. And along length is different. Okay. So total elongation will be elongation of the first part and elongation of the second part. So this is a stress of the 4D scale, and here the diameter will get double. Okay. So it will, so here it will be 4D scale, okay, or 2D whole scale, okay, and length is 12 by 3. Okay, so elongation will be summation of these two parts. The total elongation comes out as 2PL by pi d square E. Okay. So from this the strain energy is your P into del by 2, and del L is your 2PL pi d square by E, pi d square E. Okay, so it is P square L pi d square E. So finding out the ratio U1 by U2. So we take 2 to answer is your D. Okay. Next, an ideal air standard diesel cycle does not contain following process: a constant volume heat addition, a constant volume heat rejection, a C isentropic process, and B isentropic, sorry, compression and isentropic expansion. So in diesel cycle, the heat is added at constant pressure, so it doesn't contain heat, constant volume, heat addition. So answer is your A. Next, which of the following is a surface two-dimensional imperfection in the crystal structure of common metal? So vacancy is your point defect, dislocation is your line defect, okay, and grain boundaries are surface defect. So answer is C. Inclusions are inclusion cracks, pores, uh, three-dimensional bursts. Okay. So answer is your C. Next, In sand casting, fluidity of molten metal increases with option A increase in degree of superheat, B decrease in pouring rate, C increase in thermal conductivity of the mold, D increase in sand size of vessel. Okay. So in fluidity is related to uh, liquid state of the metal. Okay. So the fluidity will be more when the temperature is more and the metal is in liquid state. Okay. So uh, this is increasing with the increase in degree of separate. Okay. So let us see that what is the in the sand casting fluidity of the molten metal increases with the degree of separate. As a fluid is the ability to flow of molten metal with high degree of separate freezing of the molten metal will not take place during the fluid. Okay. Next, which of the following casting process uses expandable pattern and expandable mold? Option A, shell mold casting. Option B, investment casting. Option C, pressure die casting. Option D, centrifugal casting. So answer is the investment casting uses expandable pattern as wax which expands and due to expandable mold. Due to this expandable mold used, the wax is finally lost, so the mold comes back to its original shape and state after expansion. So answer is the D. Okay. Which of the following welding process results in the smallest heat affected zone? Okay. Uh, Unconventional welding generally have the smaller heat affected zone. Heat affected zone is defined as the area which is affected by the by heating of uh, metal during welding. So in an unconventional machining, very small temperature rise is required. So it has smaller heat affected zone. Okay, so answer is your C. So laser beam welding has very small heat affected zone. Okay, all other arc welding or gas welding and thermal welding will be having higher temperature involved and higher heat affected zone. In resistance seam welding, electrode is in the form of cylinder, flat plate, coil of wire, circular disc. So answer is circular disc. Okay, resistance seam welding, the electrode is in the form of circular disc. Okay. Which of the following powder production method produces spongy and porous particles? So automation, reduction of metal oxide, the electrolytic deposition, and polarization. Okay, so answer is your B. So it this reduction of reduction of the metal oxide generally produces this spongy and porous type of particles. Okay, so however the powder can also produce the automation, electrolytic deposition, and polarization. Okay, so answer is but the spongy and the porous particles are produced by this reduction of metal oxide. Okay. Next, the binding material used in cemented carbide cutting tool is option A, graphite, option B, tungsten, option C, nickel, and option D, cobalt. So answer is cobalt. Okay. So the binding material used in cemented carbide is cobalt, which is bound on different component of the uh, carbide tool. Okay. The grinding ratio is defined as a volume of wheel wear divided by volume of work material removed. B. Volume of work material removed. Volume of wheel wear. C. Cutting speed by feet. D. Longitudinal feet by transfer feet. So answer is B. The grinding ratio defined as volume of work material removed divided by volume of wheel wear. Okay. The grinding ratio defined as volume of work material removed. Okay, and volume of the tool or your wheel. Okay. Volume of work material removed. Okay, and volume of tool removed. Okay. So answer is B. Next, the best wire size for measuring effective diameter of a metric thread included angle is 60 degrees of 20 mm diameter and 2.5 mm pitch using two wire method is okay. So the best wire method is the best wire is one which touches the pitch line of the thread. Okay. So here the suppose this is your best wire. Okay. So answer you have to we will see option after finding out. Okay. After finding out the best wire. Okay. The best wire size of the measuring effective for measuring so effective diameter is at 20. Okay. So here, this is your best wire. Okay. So the R is the radius of the best wire, and this is your pitch line. Okay. And this distance will be P by 4, and this angle is your 60 degrees. So this angle will be 30 degrees. Okay. So and what? Okay. Now pitch is given as 2.5 mm. Okay. So now we can find. So the pitch is given 2.5 mm. So this is your 2.5 by 4. Okay. So from this angle is 30 degree. This is your 60 degree. This is 90 degree. So this will be your 60 degree. From this triangle, we can find out uh, that R. Okay. So AB is P by 4 divided by R is your cos uh, P by 4. Okay. P by 4 is your base. If it be considered angle divided by hypotenuse or this angle will be at 30. Okay. As this is 60, so this will be 30 because this is 90. Okay. Cos 30. Okay. So answer is yes. Now, from this we can find out R because we have P is 2.5. R is your this point 7216 and the diameter of wire is your 1.443. Answer is your A. Okay. So the best wire is wire which touches the pitch line at the point of contact. This is the point of contact in the pitch line and touches the pitch line. Okay. So answer is A. Next. The number of defective produced by a Six Sigma process in parts per million is so number of defective produced is 3.2. That is we have to remember. Okay. In 3.2 in 1 million parts. Okay. So this is quarter Six Sigma process. Okay. Next. A manufacturing cell has five machines A, B, C, D, and E. The average cycle time in minutes for a job on each of the machine is given in the following table. Machine A, B, C, D, E. Average cycle time 5, 6, 5.5, 4, 4.5. There are three operators in the cell. The first operator operates machine A and B. Second operator machine C. And third operator machine D and E. All the jobs have to move in the following sequence A, B, C, D, and E. Assuming the job transfer time between two machines is negligible, the average cycle time in minutes for manufacturing of food from manufacturing cell is okay. So here the time for machine A is a 5 and for B it is 6 and for C it is 7.5 and then for D it is 4 and for E it is 4.5. The total number of total time is your 25 and total number of cell are A, B, C, D, E. Every time is your 25 by 5. That is 5 answer is E. Okay. Next, for a simple moving average forecasting method, as the length of averaging period increases, the forecast sensitivity option is increases, B decreases, T remains constant, cannot be repeated. As explanation is, as the length of the averaging period increases in the moving average forecasting method, the forecasting sensitivity decreases. Okay. The smoothing factor increases as more weightage is given to fast time. Okay. So as the length of the period increases, we we include more fast demand. Okay, fast demand. Okay, and we uh, do not put emphasis on the recent demand. Okay, so the forecast sensitivity always depended upon the recent demand. Okay, so it decreases because less weight is given to the recent demand to answer your question. Next, a dedicated machine receives jobs at a rate of 20 per hour and the processing rate of machine is 30 per hour. Assume the following: 1. Inter-arrival time and processing time for jobs follow exponential distribution. 2. Q discipline is the first come, first served. Okay. 3. The queue capacity and job population are infinite. For how much time in minutes on an average does a job have to wait before it gets loaded on the machine? Option A 4, option B 3, option C 5, and option D 6. Okay. So the queue discipline is first come first served, and the queue capacity and job population are infinite. Okay, these two conditions are given. So inter-arrival time and processing time for the job follow. So the these queuing theory is following exponential distribution. Okay, that is given. Okay, so the arrival rate is your 20 per hour. Okay, and the processing rate is, or service rate is your 30 per hour. Okay, so waiting time in queue is your given by this formula. Okay, so this is the waiting time. Uh, the job has to wait before it gets loaded on the machine. So answer is your 4 minutes. Okay, or 2 by 30 hours. Hours. Okay, and minute that is 4 minutes. Okay. Next, a system that acquires knowledge creates a knowledge base and applies a large but standard set of probability based rule to make a decision in a specific problem setting is termed as an expert system, B, a management information system, C, a database management system, D, a probabilistic assessment system. The answer is expert system because it requires knowledge, and expert is always varying knowledge, and he applies to he applies to the standard setup. Okay, the standard set. Okay, so answer is your expert system uses both knowledge based and probability based rule to make decisions. Okay. Next, which one of the following is not a method of calculating depreciation? A straight line method, B sum of year digit method, C declining balance method, uh, D net present value method. So NPA is not the method of calculating depreciation. It is the method to uh, calculate the present value of the money. Okay, that we are getting. Okay. Next, in a value analysis exercise, cost of product has come down by 20% without any change in its quality. The product has improved by option A 15%, option B 20%, option C 25%, option D 30%. Okay. Now it is given that the product has cost has come down by 20%. Okay, and the product value is inversely proportional to the cost. Okay, as the cost has come down by 20%, or now the cost is your 0.83. So P1 is here. So is equal to 1 by 0.86. Okay. So this is a new, this is a reduced quality or value. Okay. And present value is this. Okay. The ratio of P1 by P is what? 1.25. So its quality has been increased by 25%. Okay. So answer is here. C. Next, it is proposed to conduct a work sampling study of workers in machine shop. Which of the following information would be necessary to determine the number of observations? Option A confidence level only. B, accuracy only. C, both confidence level and accuracy. D, rating factor. Okay. In work sampling, both the confidence level and accuracy are desired to determine number of observations. Okay, answer is C. Okay, next, the eigenvalue, 2 marks question. The eigenvalue of the matrix are 10 minus 4, 18 minus 12. Okay, this is a matrix. Okay, option A 4, 9, option B 6 minus 8, option C 4, 8, and option D minus 6, 8. Okay, the eigenvalue is determined by subtracting lambda from this diagonal element and then solving it. Okay, so 10 minus lambda minus 4, 18 minus 12 minus 3 lambda. Okay, now solve this product leads to and subtract the product leads to. Okay, it will be 72, and this will be here. So in this manner we can find out solving this quadratic equation. We can get uh, lambda, that is 6, and minus 8. So answer is your B. Next, if Pxyz is equal to x square plus y square plus 2z square defines the temperature at any location x, y, z, then the magnitude of the temperature gradient at point P is equal to P111 is. So this is your this is the equation of temperature or variation of temperature with respect to x, y, and z. Okay, and gradient T is nothing but delta T, del T. Okay, so del T is your if we multiply this del with T, then we get curly T by curly x, I plus curly T by curly y, j, curly T by curly k. Okay, so T, putting the value of T, so differentiation of T with respect to x is your 2x, and differentiation of T with respect to y is your 2y, and differentiation of T with respect to z is your 4z. So it will be 2xi, 2yj, and 2 and 4zk. Putting the value of x, y, and z as 1, 1, 1. Okay. So gradient T will be your 2i plus 2j plus 4k. Okay. So the magnitude of gradient T is your 24. So 2 square plus 2 square plus 4 square. Okay. So it will be 2 root 6. So option A is the right one. Option A is the right one. Next, the value of integral c z square divided by z4 minus 1 dz using Cauchy internal integral round circle z plus 1 modulus is equal to 1, where z is equal to x I y is. Options are A 2 pi I, B minus pi I by 2, C minus 3 pi I by 2, D pi square I. Okay. So this is your equation. Okay. Z square equal to Z square by Z4 by minus 1. Okay. Now Z square minus 4, Z4 minus 1 is can be written as Z square minus 1 plus Z square plus 1. Okay. And further this Z square minus 1 can be written as Z plus 1 Z minus 1. Okay. Now by partial fraction, this can be assumed as A by Z plus 1, B by Z minus 1, C Z by D, Z square minus 1, Z square plus 1. Okay. And now solving this. So first of all putting Z is equal to 1. Okay. So this term will be 0 and this term will also be 0. So we can get B. So B is your putting there in. So B is your here 1 plus 1 2. Here 1 plus 1 2 again. So B is your 1 by 4. Similarly, we can find by putting Z is equal to minus 1, we can find out A. So A is your minus 1 by 4. And comparing the coefficient of Z square, here Z square coefficient is 1. Here it is A minus A, and here it is B, and here it is D. Okay, so A minus A plus B plus D is your uh, 1. Okay, and A is your minus 1 by 4, so it will be 1 by 4. B is your 1 by 4, so it will be 1 by 4. So D can be written as 1 by 2. Now comparing the coefficient of Z. Okay, and there is no Z on the left hand side, and on the right hand side there will be A Z, okay, and B Z, and C minus C. Okay, so from this we can get because A is minus 1 by 4 and B is 1 by minus 1 by 4 and B is 1 by 4. So C will be 0. So this equation can be written as this, like this, minus 1 by 4 Z plus 1 plus 1 by 4 Z minus 1 plus 1 by 2 Z square plus 1. Okay. So the line integral can be written as like this. Okay. Now given that modulus Z plus 1 is 1. Okay. And Z is your x plus I y plus 1. Okay. Or we can write x plus 1 square plus y square is equal to 1. Okay. So it means the radius of circle is 1. Okay, and its center is your at minus 1 and at y0. So this center is this. Okay, radius is 1 and center is your minus 1 0. Okay, so it means uh, in this equation, z plus 1 and z minus 1 and z square minus plus 1. Taking these. Okay. So z plus 1 is 0 and actually the value of z is minus 1. So the point minus 1 lies inside the circle and lies at the center. Okay. And second is your z minus 1. This is z minus 1 and z minus 1 is 0. So z is 1. Z1 is lying outside the circle. So it's okay. Similarly, your z square plus in third term, there is z square plus 1. So z is will be having plus minus iota. Okay. So this will be they will be having this these points. Okay. So uh, so we can see that this is lying inside the circle, this is lying outside the circle, this is also lying on the inside outside circle. So the integral of the term which are outside circle is 0. Okay, and now we have only this term. Okay, so for this term we are having as the point lies inside the circle. So it will be the 2 pi fz and fz is your minus 1 by 4. So minus 1 by 4 2 pi I, or the answer is minus I by 2 I either, or option is your B answer. Okay, so answer is your B. The value of 0 into limit 0 to 1 integration e minus x square dx using trapezoidal rule for 10 trapezoids equal to option A 0.6778, B 0.7165, C 0.6985, D 0.7462. Okay, so here this value is fx is your e minus x square. Okay, and the as they are 10 trapezoidal function and the limits are 0 to 1, so the h is your 0.1. Okay, so trapezoidal step size is 0.1. Okay, so at so starting with 0, first is 0.1, then 0.2, 0.3, 0.4, and up to 1. We will find out the value of fx. Okay, by putting these different values. So this is the value of fx. Okay, now using trapezoidal rule, according to trapezoidal rule, the integration is h by 2 y naught plus y1 yn plus 2 bracket y1 plus y2 up to n minus n. Okay. Here y naught is your 1 and yn is your 0.368 and y1, y2, y3, y4 are these values. Okay. So putting these and h is your 0.1. So putting these values we get answer 0.746. So answer is your next. A cantilever beam of length L rigidity rigidly fixed at A is uniformly loaded with intensity Q downward over two-thirds of its length from free end. B. As shown in figure, the modulus of velocity is V and moment of inertia about the horizontal axis is I, the angle of rotation at free end of the free end. And the free end under the applied load is the angle of rotation. Okay. So options are 7 QLQ by 40 B 13 QLQ by 72 C 11 QLQ by 60 D QLQ by 24 So this is the question which is for which the marks are given to all. Okay. So but we are solving it. Okay. So and getting the right answer. Okay. So here the sport is R. So if here there is fixed sport, so there will be reaction and moment. And reaction is your RA and moment is your M. Okay. And this is uniformly distributed load over a length of 12 by 3. So finding out RA is your nothing but total upward load, total downward load is your total upward load that is Q 2L by 3. Okay. So RA is your 2 by 3 QL. Okay. So now next is moment. Now taking moment about A. So taking moment about A. So Q into 2L into 3, 12 by 3, Q into 12 by 3 total load, and it will be acting at 12 by 3. Okay. So this is the 12 by 3, 12 by 3 by 2, or from this end it will be 12 by 3. So I measure this moment. So I measure 4L square Q by 9. Okay. Now using Macaulay's method, but so R into X minus M. So taking that distance X, so human will be R into X minus M and minus this Q into X minus L by 3 here by 2. Okay. So putting mx is equal to e d square by dx here. Okay. So R into X, this is the right side is same. Now integrating will give integration will give R x square by 2 minus mx minus q x minus l by 3 cube by 6 plus c1. Okay. Again integrating ei by rax cube by 6 minus mx square by 2 minus qx minus l minus 3 4 by 24. This is the method of integration that will not open the bracket and we will integrate taking it as variable term. Okay. So c1x plus c2. Okay. So at x is equal to 0, there is no deflection, y is equal to 0. Okay. So this is your 0. So this is your 0, this is 0, this is equal to 0 because whenever negative, in this method, whenever negative sign comes out in bracket, we will take it 0. Okay. So this will be 0. Okay. And from this C2 will be 0. Okay. And at fixed end, the slope is also 0. So x is equal to 0, dy by dx is 0. And from this equation, we can get P1 also. P1 also as 0. Okay. Now the equation of slope becomes like this: e dy by dx, because c1 and c2 are 0, r x square minus by 2, sorry, minus mx minus qx minus l by 3 cubed by 6. Okay. Now slope at the free end. So at the for the free end we have to put x equal to l. So putting x equal to l, so ra l square by 2 minus ml minus ql minus l minus 3 cubed by 6. Okay. So here RAL square by 2 ml minus ml 8 QLQ by 27 into 6. Okay. So this is your the put is the value of RA is your QL by put in the value of RA is your found. RA is your 2 by 3 QL and M is your 4L squared by, okay, put in a value of RA and M, and M is your 4L squared Q by 9, and okay, so by solving this, we can get slope as minus 30 by 81 QL cube by EI. Okay, so option B will may be correct if 81 is replaced by 72. So that's why the marks are given to all in this question. Okay, next, a short column of length L. In this question, the marks are also given to all. Okay, a short column of length L having cross section area of 50 mm by 100 mm is pinned at end. The proportional limit of the column is 250 MPa and the modulus of elasticity is 200 GPa. The minimum length of the column at which it buckles elastically is given that let P be the load on the column and the proportional limit is of the column is 250 MPa. That's by 2 MPa. 50 MPa. The area is 100 into 50, so 500,000 mm square. And load is your uh, so this is the area, this is the stress. Load is your 250 into area. So for the pin jointed end, the potential load is your pi square Pi by L square. Okay. So PV is your 1 to 5 0 0 double 0. Okay. Now putting this is your convective load. Okay. Okay. Now we have found out P. Now putting the P, this P equal to this, gave it like as a column. So L will come out as 1.82, 1.2 meter. So nearest option may be your D, but the marks are going to hold. Next, in a steady state and adiabatic flow of air through a horizontal nozzle, the pressure and temperature drop from 1.5 kPa. Reading out again. Okay. In a steady state and adiabatic flow of air through a horizontal nozzle, the pressure and temperature drop from 1.5 kPa and 300 degrees Celsius. Sorry, it is 105. Okay, 105 kPa and 300 degrees Kelvin to 100 kPa and 296 Kelvin, respectively. The air is considered to be perfect gas. Take specific heat at constant pressure. Cp is equal to 1005 joule per kilogram per degree Kelvin. Density is equal to 1.15 kilogram per meter cube, and the ratio of specific heat gamma is equal to 1.4. For air, if the kinetic energy at the inlet is negligible, then the velocity of the air in meter per second at the nozzle axis is option A 85, option B 90, option C 93, option C D 96. Okay. So the temperature at the entry is just 300 Kelvin and temperature at the exit is just 96 and Cp is just 1.005 for in kilojoule per kilogram per degree, not in joule, it is 1005 joule per kilogram per degree. Okay. Now this is your entry, this is your exit. Okay. Now applying the steady state equation at 1 mm and 2. So here it will be H1. This is H1. Okay. And Q, there is steady state energy, and as there is no heat is being supplied, so Q is 0 and no work has been done, so Q is 0. Okay. So this is your H1 and this will be your V1 square by 2G by 2. Okay. And Z1 and Z2 are same because height is same. So the steady state energy equation reduces to this H1 plus V1 square by 2 plus is equal to H2 plus V2 square by 2. Okay. So and initial velocity is negligible. Final energy at the inlet is negligible. So V1 is 0. So now we have H1 and H2. H1 and H2 is nothing but 2 Cp T1 minus T2. T1 and T2 we are having, and Cp is your 1005. So putting these values, you can get velocity at exit, that is 90 meter per second. Okay, we'll solve rest of the paper in next video. Okay, thank you.